Now I like to call on it. Hi everyone, welcome back. This is Balajan Natarajan. Thanks a lot for your valuable time today on Saturday to learn and inspire and grow. And thanks to the speakers. So very well done on the psychotsast. Quickly, this is the moment for cherishing and thanking people who have offered us the space today. I'm welcoming Prabhu, who is the Vice President of SQ1. Let's give a round of applause to SQ1. Okay, Prabhu, how are you today?
Good, good. How are you guys today? I hope everything is, accommodating.
You guys are giving like a hotel hospitality, so really nice to see this gesture. What drives you?
Don't expect any rooms.
Okay, so what drives you to offer this type of help to the community groups? What's behind this?
Kind of not taken from my experience. So I've been, in the industry for almost 12 years, and I was, within a small group, was just taking care of the office, work, house, family. So typically, I wasn't exposed to work outside. I didn't have much, except for any official, talks and other things. I hadn't much experience with peers in the tech. So at one point of time, I took a step okay, let me explore outside as well. So when I started growing and I met few people, I thought this should also be done for my people who are working here. So that is the reason I spoke with the management. We thought, okay, let us start hosting community events. So two things. One, we are, though SQL, we have been in the industry for almost 15 plus years, we are not known much. So I wanted the brand to be known, not for the business purpose, for that sales team, marketing team, they are working separately, for resources, for the people. So I wanted people to know what kind of organization we are and how is our work policy and other things. So, and apart from that, I also wanted, that my colleagues, to get knowledge from outside, to explore outside, see what is happening, always, compare what is happening outside so that we stay up to the standards. So those are some of the things we started these posting sessions for various communities.
Great gesture, Prabhu. It's a nice gesture in terms of you are making a win-win. You are helping a community group to come together and then talk about engineering and its excellence, and thereby you are supporting. So nice gesture. So tell us more about what your company does, Square One Technology. And I see that you guys are now, interestingly, I'm part of the board of Saka Chennai chapter, and then I'm associated with the Saka Chennai chapter for around 20 years, 2 decades almost. So serving board since 2017. You are being one of the diamond sponsor, which comes at a very premium price. And even our conference single ticket goes to around 10,000 minimum, and then it goes to 20,000 max. So, what is that your company does? Are you part of cybersecurity? What type of products and solutions you guys offer?
Okay. So, Secure One, we kind of, I joined Secure One before almost, it's close to 10 years now. So, we started originally in Mylapore. At that time, we were known as Secure One INC. So, kind of like, we were primarily into cybersecurity services. So, we are not concentrating on any other things except for cybersecurity services and compliance implementations, especially on the GRC side. And kind of went and we started giving services to various clients, primarily in the US, Middle East, India, and UK. And at one point of time, we thought there is a huge gap in the products which we use for our services. We thought, like, why not start developing our own products as well? So that is when we started developing our products. So we had a couple of products, but we didn't use it as a SaaS platform. We just use it for ourselves when we deliver the services. But now we thought, okay, let's start selling the products as well. So we are working on a few products as of now, and they are in the final stages of releasing, and we'll be going full-fledged with those things. And now we are rebranding to SQ1 Security. The main reason is, again, it's an interesting story. So we wanted Secure One. So SECURIONE domain was not available. So we added a Q in between. And people started calling it as Square One. You did it. And again, everyone thought, like, when we send an email address, they take it that we have made a typo and they track themselves to secure1.com and they send me a wrong email. So we thought, okay. So again, that Q stood for us a long time. Yeah,
It actually works.
so that Q stood with a long time. So I thought, like, SQ1. So the management decided we'll go with SQ1. So we rebranded ourselves to SQ1 in short name.
So in terms of the product, I see you something like SQ1 Shield. You want to touch upon that?
SQL Shield is kind of a legacy product which we use for ourselves to deliver the services. We are not selling it outside and other things. As of now, we are concentrating on three products. One is vulnerability management, it's called as Scanify. And we do another product for automated GRC implementation called as Stackful. And we are working on our SOAR solution as well. It's called as Jackson. So we kind of, like, thought, again, all this SQL Shield was our product. It's again in the, it was almost all the products combined together. You would have a GRC implementation, you would have a SIF platform, you would have a vulnerability management, everything combined. So we use it for giving service. Now we split it up. Add the new gen, we need to add AI to the products. That's a mandate. So we kind of, identified where are the things where we can use AI to the products, and we kind of develop, and we are almost in the final stages of using those things.
Awesome. So how big is SQ1? How many people are working here and across the globe? Any?
So as of now, we are almost 150 in US, India, and a small team in Bangalore. We have a small team in Bangalore. We have started recruiting in Pune. We are planning to open office soon in Bangalore, and maybe in the near future in Pune. We have our type of usual headquarters in US. It's in Dallas. So we have a separate team in US. We have a director from US who's taking care of those things. We have a SOC, Security Operations Center here, one in Chennai, the same floor, and we are having one in Dallas.
Okay. And is there any openings? Because there could be people who will be interested in, they may be.
There are lots of openings.
Okay. So they have to visit your site and then apply for it?
I think you guys could get in touch with our team, or you could just send an email to HR at SQ.
Anyone here from HR of SQ1?
I think the HR team, they had some plans today, so they came and left. But I think Sai is there, though he's from the sales team, he can guide you through, and my engineering team is there, so they could guide you as well. So
Anyone looking
we
for
could have a
some-
live interview with my engineering team here itself. So Kutu, who's our lead engineer is here. So I think Chitu and Ram could.
Anyone
If they
looking
are
for-
okay, I'm okay usually.
Anyone looking for interesting opportunities, they can reach these people. And maybe a last question, right? Who are the promoters and any word about them? Who is driving this SQ1?
Okay, SQL was founded by two founders, brothers. One is Satish Narayanan and Suresh Krishnan. So, unfortunately, Satish, I asked him to come today, but he was stuck in another meeting, so he was not able to come. But it was founded by these two people. They are from Chennai. And we have one director in US, Chris Mastrini. And apart from that, rest of the team, we are all working from Chennai, and few sales and other people from the US.
Okay. Thank you. Nice interaction. And once again, a warm thanks from Chennai platform.
Thanks, guys. Thanks for taking your time on a Saturday. Coming here to share your knowledge. Feel free, whatever you want. I think our team can help you if you need anything, and wherever we can be of assistance, we are glad to be of assistance.
Thank you.
Thanks, Bola, for organizing this event. Very professional. Thank you so much. Thanks, guys.
Thanks, Babu. Thanks, Babu. Next, we will have the second session. I'll hand it over to Bhaskar.
Very good morning. I'm Bhaskar. I have 5+ years of experience in DevOps and senior DevOps engineer. And today we are going to see a very interesting topic, which is Kubernetes, the Kubernetes Hydra, which is nothing but scaling beyond the single cluster limitations. So, what is Hydra? Does anybody knows what is Hydra? Anybody knows what is Hydra?
Say one more thing.
What is Hydra? Hydra, just Hydra.
We don't know.
So Hydra is nothing but a multi-headed serpent. It's a kind of metaphor in Greek mythology, which is nothing but a water snake with multiple heads. So it has multiple heads. So representing we have multiple clusters in Kubernetes, and it has one body but multiple heads. Where we have all fundamental of Kubernetes into fundamental Kubernetes in all the clusters and APIs. And also there is no failure of if one head dead, right, other head will work on that Hydra. So the same thing will apply for Kubernetes also. The failure of one Kubernetes cluster doesn't bring down the entire application, whereas the other cluster deployed across multiple applications will serve the traffic, and it may become more resilient and scalable for an application. And what is multi-cluster and multi-deployments? So multi-cluster is nothing but operating managing two or more clusters instead of deploying a single application in one cluster, and it has one control plane. And whereas in single cluster we have only single control plane, we have multiple pods in a cluster. So whereas in multi-cluster we have multiple pods, and it's hosted in individual control plane, network, and resources. So it will be easy for the end user to access the cluster based on the geographic location, and also we can isolate the clusters based on that. Different departments or different applications, and each application team can deploy their code in different clusters. And what is multi-cluster deployment? So this is the kind of single application or workload where we can deploy across multiple clusters. Instead of deploying all the applications in a single cluster, we can deploy individual application in individual clusters, and which results in high availability, and also the traffic distribution for each application will be across the all clusters, and which will improve the optimal performance of an application. And why multi-cluster Kubernetes? What is the key benefits and what is the advantage of multi-cluster instead of single cluster? So since we have multiple cluster in Kubernetes, so we will get high availability because of multi-cluster, and we have multiple clusters, right? We can deploy same application in multiple clusters, which results in more disaster recovery. If anything goes on in one cluster, we can switch the traffic from primary cluster to the secondary cluster where we have a list of applications, which results in disaster recovery purpose and scalability, and also performance. So since we have multiple clusters, the traffic will be distributed across the clusters, so there won't be any performance related issue, and there won't be, we can improve the latency also. There won't be any latency for an application. And the other thing is cost optimization. How cost optimization will help in multi-cluster? In single clusters, we have multiple pods, multiple resources, and multiple CPU, and everything will be there. Whereas in multiple pods, we can define how much application wants. If let's say we are deploying our application on a single individual cluster, right? We know how much traffic will get to our cluster. So based on that, we can constrain the resources, which improves the cost optimization of a multi-cluster. And how we can approach multi-cluster in Kubernetes. So there are two approaches. One is network-centric management and Kubernetes-centric management. Network-centric management is more or less related to network, which has load balancer, CDN, and history of service mesh, where we can manage the traffic between the, where we can manage history of service mesh to connect between clusters, interconnecting clusters. So this is the most common approach that will be used in recent days for multi-cluster, and which uses load balancer. Either it can be GCP load balancer, which is hosted globally, and from where we can switch the traffic between clusters. And another thing is Kubernetes-centric management. This is very legacy approach which is followed in Kubernetes multi-cluster management. It's kind of configure everything in a single control plane of Kubernetes. So all the configuration of multi-clusters will be configured in single control plane, which is nothing but Kubernetes configuration file, and which is very least in nowadays, and it's not approachable approach for a multi-cluster Kubernetes. So we'll go with how network-centric approach will be used in existing application, and so this is how multi-cluster looks like. So by general, single cluster will have a single control plane, and it will have multiple nodes. Whereas in multiple clusters having multiple control plane, and it will be access to that load balancer, Google load balancer. So the end user request will go to the load balancer. From load balancer, it will split the traffic across the globe based on the geographic location or whatever metrics or whatever configuration that we did. Based on the end user location, it will send the traffic to the nearby cluster, and from cluster it will go to the control plane. Each cluster will have a control plane, and then each control plane will have multiple nodes. So based on the availability of the node, and each node will have a pods, right? So based on the pods availability, the traffic will be split upon multiple clusters. So this is a generic basic multi-cluster diagram of multi-cluster. This is based on the network-centric approach. And this is a just simple configuration for how we can configure our multi-cluster in kubeconfig file, which is a basic file for our cluster configuration, where we can define how many clusters we want. It's kind of similar file that we have in help values that will get multiple ingress in Kubernetes. We'll have multiple ingress. So same kind of configuration that we have in clusters here. So where we have to define how many clusters that we want. So here in cluster section, we have to, in context, we have to define like how many clusters we want. Cluster number one is getting one user is Nick, another one is demo. So it's about the number of clusters. Let's say simply how many. If someone asked how many clusters do we have in our application, simply we can say how many clusters we have in this context, kubeconfig context file. How many clusters we define. The same number of clusters will be there in multi-cluster configuration of an application as well. So this is a simple command that we can use, or we can switch between the clusters. Let's say we are running an application in one cluster, how we can switch from one cluster to another cluster. That we can use using context. That's a command, and then we configure in this file. Where when we want to switch from, let's say from cluster number A to cluster number B, we can define here the username is Nick here, right? So the same number of same kind of command can be used to switch between the clusters by using this command. So let's say we are running application in cluster A. Now we have to move the entire application traffic to cluster B. Then we have to configure this in the command, and the entire task will be moved to cluster B and it will serve from cluster B traffic. And what are the key aspects of multi-cluster? So why we are using multi-cluster and what are the key aspects that is there in the multi-cluster? One is inter-cluster network connectivity. Since we have multiple clusters, right now we are using single cluster, and within clusters we can connect multiple pods and applications. So we can connect application between multiple clusters. So the primary goal is to enable seamless communication between multiple clusters. It can be done through STO and STO service mesh, where STO service was employed in network. And what STO will give is it will give advanced traffic management between the clusters, and also it will give security features. So there won't be any security vulnerability for an inter-cluster communications. Another thing is traffic management and load balancing. So network-centric approach is mostly based on the load balancing and traffic management. Here we can use a load balancer. So let's say we are end users send the request to CDN. Whatever CDN, from CDN the request will go to load balancer, and from load balancer the traffic will be split across multiple clusters. So to split the traffic across multiple clusters, we need a load balancer. Either can be GCP load balancer or any other cloud load balancer that we can use. And this is a key aspect of multi-cluster. Another thing is network segmentation isolation. So since we have multiple clusters, there is a chance that requests may go to cross cluster, which results in application downtime, or we can get some other bad requests. So this is the key aspect of multi-cluster, where we get isolation of clusters. So one cluster should not interact with we should not get cross cluster communications, which results in bad response of the request, which will impact end user performance. So network segmentation is a key aspect, one of the key aspects of multi-clusters. And then multi-cluster deployment strategy. So we have how we can deploy our application in a multi-cluster. So right now we'll deploy our code to a single cluster, and it will have multiple pods. We have a workload where we have individual application. Each application will have 2 pods. How it will be applicable in a multi-cluster. So in application deployment, we have 2 steps. One is replicated deployment, and another is split-based service. Replicated deployment is nothing but deploying the same application in multiple clusters. This will be used for disaster recovery purpose. So where we can use one cluster as a primary, and if one goes down, then we can send all the traffic to secondary. For this kind of purpose, we can use replicated deployment, where we can deploy same set of applications in both clusters. Another thing is split-based service deployment, which is nothing but deploying different application, different services, different clusters. So where in replicated deployment, we can call it as active-active, where we can have a same set of code in same 2 different clusters. And active passive, where we can use different clusters for different applications. And global traffic management, which is DNS based, and CDN integration. So we have to have a load balancer across the cluster. The cluster should connect it to load balancer, whatever cluster we have, and that load balancer should connect it to CDN, because all the applications will have a CDN hostname, and CDN hostname only from CDN hostname the request will go to load balancer of the cluster. So this is one of the key configurations. And inter-cluster communication, as I mentioned here, we are using the service mesh STO. So because to connect between the clusters, because we have hosted one application, one cluster, another application, another cluster using script-based service deployment. In such case, we need a service mesh to connect between two clusters. And technical approaches and tools that we need for multi-cluster. So one is configuration management. So by default, clusters will have a default configuration where we need to have what is the DNS host name and what is the application that we need to deploy. So for that particular configuration, we need to have a configuration management, and it can be done using help, which is a package management, which you could see in that quiz question is there, right? It's a package management with multi-environment template. So help is the one of the best approach, and the tools that we need for multi-cluster configuration, which can be able to, with that we can manage multiple clusters for an application. Another thing is Argo CD. Argo CD is single source of considered multi-cluster deployment. So we can help is for configuration, and to deploy applications we need Argo CD, and load balancer to distribute external user traffic across the cluster, and the service mesh and STO, which is nothing but cross-cluster networking does, and secure communication between the clusters. So communication between clusters is more important in multi-clusters than a single cluster, because cross-cluster networking is the key important thing to connect between two applications. Let's say we have one application in one cluster, another application is another cluster. If say from front end we are accessing some link which will send request to application number 2, which is hosting multiple cluster A, cluster B, from A to B. To connect them, we need cross-cluster networking that can be done to service mesh and gateways. And another thing, key benefits of multi-cluster deployments. One is high availability and resilience. So there won't be, we can say there will be less single point of failure, because we have multiple clusters. If it is single cluster, if it goes down, then it will take some time to make sure improve the uptime of an application. So if it is multiple cluster, we can switch the traffic, so there will be high availability and improved uptime of an application. And another thing is scalability and performance. So if you have single cluster node, we have limited resources and limited nodes, and because all applications are hosted in single cluster, we can't handle traffic. If you want to increase the traffic, then we have to increase the resource of a cluster, CPU and everything. So if it is multiple cluster, each cluster will have an individual application, and individual application will have individual resources. So with that, the scalability and performance of an application can be improved if you use multi-cluster. And business continuity. As I mentioned before, it can be used for DR recovery purpose and other things. If it's any failure happen, we can switch the traffic to another cluster across the region. And another thing is it will be used for developers. We have multiple clusters, right? With one cluster, we can route the traffic internally, where with another cluster, we can route traffic to end users. So if they want to deploy and check any code, they can deploy the code in any one cluster. So they can result, let's say they want to upgrade any version, and they want to test it in before it will be rolled out to end users. So in such case, because sometimes the code will work in lower environments, whereas in production sometimes it faces issue. The same code can be deployed with the new tools and version, and can be deployed in cluster A, and it can be tested. And then it can push to cluster B if we have multi-cluster. In such case, it will improve the developer experience also. With that, we can push the code to production, and there won't be any impact to the end users, and we can make sure the application works fine in production before we can give it to end users. Another thing is, as I mentioned, cost optimization, resource efficiency, because cluster uses for specific workloads, and resource efficiency because, as I mentioned, single cluster will have one limited set of resources, CPU, memory, whereas in multiple cluster, it will be based on the application need. So in such case, cost will be optimized and performance also improved. Monitoring and observability. So this is the key thing for a multi-cluster application, because in single cluster, it's a kind of managing a single cluster is easier than managing multiple cluster. Whereas in multiple clusters, we have to monitoring and observing is the key thing, because having multiple clusters and we have a cross-cluster integration, and to make sure there is no cross-cluster connectivity or any issues, we need monitoring and observability for a multi-cluster. So we need to aggregate all the logs of a single platform, single all application, and we need to monitor the logs, and we have to set up an alert we have to measure CPU, memory, and whatever configuration that we have in multiple clusters that needs to be monitored. And cross-cluster alerting is the key thing, because there should be network isolation between the clusters to avoid any cross-cluster request, which results in bad performance of an application. And we have to track individual traffic which we got for different clusters. to enable the precise performance of an application, which is a key thing to improve end user performance. So let's say we are accessing one application from one cluster, and we have to compare the performance between the multiple clusters. So if any cluster is having any performance issue, then we can easily identify. Since because we can't have all clusters monitoring in a single tool, right? So we need to have distributed tracing across multiple applications, which will easy to improve the performance of individual application hosted in multiple clusters. And this is the high-level multi-cluster architecture. So whatever I spoke is almost there in a single slide. First thing is we have to develop a code, and developer has to push the code in Git repository. Once the code is pushed, then CI pipeline will be triggered, and image will be created, and the Docker image will be created, which pushed to artifact registry. And then we have to update the GitHub's configuration. So where we have Helm configuration and those things for a multi-cluster, so that needs to be updated. And once that is done, the configuration setup is done, then we have to sync with the Argo CD, which is nothing but a deployment port, which is a CD port, to detect the change in the configuration and to apply the specific application to the whatever we configured in Helm values. So we have to make sure that application deployed in the current application of the cluster. So let's say if you want to deploy any application A, it should deploy only in cluster A. It should not deploy in cluster B. It will result in a bad performance. So that kind of configuration we need to update, and based on the configuration update, it will sync and it will deploy the application by using the Argo CD and multi-cluster deployment. It will automatically deploy the version in either cluster A and B based on the deployment strategies that we need. Either it will be a replicate strategy or split-based service strategy. Based on the strategy that we configured in the GitHub's configuration, it will deploy the application in either cluster A or cluster B. Another thing is service mesh management, which will list your service mesh we are using here, and it will manage traffic between the clusters and interconnectivity of the clusters. So, issue service management is the key thing to manage this traffic across the clusters, and the global traffic routing for a load balancer, which directs the incoming user traffic to the particular clusters, and nearest healthy cluster is the key thing based on the geographic location and cluster health. So sometimes the cluster may go down or pod has an issue. So global load balancer should detect that and it should render traffic to healthy nearby cluster, so that there won't be any user performance for an application. And as I mentioned, there should be centralized observability should be there for multi-clusters. We can use any Prometheus, Grafana, or Dynatrace to monitor the application, and we can create dashboard, which should have unified monitoring for each cluster and alerting, so that it will be easy for an application team to work on the alert based on the cluster, which cluster has false positive and which cluster has an issue. So they can look into that and then they can fix it accordingly. So with that, we came to a conclusion where why multi-clusters is essential for nowadays. This is to achieving next generation cloud native scale, and right now more or less the key thing that we is doing in day-to-day life, and to achieve such kind of things which have multiple applications, we can use multiple clusters and which can deploy each clusters in each applications. So it will be easy for us to improve performance, and for future development tighter integrations using Kubernetes configuration and the recent technologies that we have. So it will truly seamless for multi-cloud operation. It will be a seamless process that we can implement. Yeah, for that I can conclude here. If you have any questions, let me know.
What is the cross-cluster communication?
Using service mesh configuration, service mesh history, which are interconnected between the clusters. We need to configure service mesh history.
It creates complexity in configuration management. Right? Let's say I have a customer service and I have an account service, payment service. These are individual services that are done. In one cluster.
So just to rephrase the question, let's say I have a customer service which internally uses account service, payment service, and whatnot. In one cluster, the configuration between the customer service to these internal services will be on a certain network because it's in a separate network altogether. The other cluster has the same combination, same code, same set of services, and its communication happens within that network. If it is load balanced, when the request comes to the customer service, how do you ensure that there is a consistency in terms of where the request routes to between these calls? Let's say it goes to the customer service. For the first call, it goes here and it makes a call to the account service. how do I ensure that the configurations are consistent? Because in this case, the configuration will be specific to this cluster. The internal IP that I configure for my payment service, account service will be specific to this. On the other case, it will be totally different. So how do you ensure cross-cluster communication?
Each cluster will have a control plane. The request will go to load balancer, from load balancer to control plane. The control plane configuration, which is there in this queue, it will send the traffic to individual cluster based on the request.
Even for the internal routing that happens within the services.
I say like deployment approach strategies. So there is a few more things: active, passive, and active, and we do have hybrid and multiple. Hybrid is nothing but if you have one cluster in servers, right? Digital host, and we can have another cluster in cloud. So such kind of multiple options we have, and we can also connect between the individual multiple cloud. Let's say we can connect between AWS and GCP also. That's specific.
Within the cluster is, I think I have that clarity, but cross-cluster communication where the customer service on cluster B talks to the account service that is on cluster A. How does that happen? Because
that is happened in service mesh history of configuration that we have.
so you open up these ports, you open up the connectivity between these two clusters.
Yes. For that only we have a shared service mesh which manages the traffic management between two clusters. So that particular configuration is service mesh, and it will have a secure purpose also, security also it will have. So there won't be any inter-cluster connectivity.
Stateful. Okay. And when we talk about observability, if I want to do a tracing in terms of what happened to the request that came in, if it has gone to the other cluster, will this not complicate in terms of troubleshooting?
That is one of the small disadvantages of this, but it's up to us to configure the monitoring system according to individual clusters. So that's why I said it's a key action, right? Because a single cluster will apply or line trace or whatever monitoring system. You don't want a particular cluster only. If it is multiple clusters, we need to set up monitor as much as possible to very in-depth we have to configure. So that we have to get alert. We have to get alert for individual clusters. So that it will be easy for us to identify which cluster has an issue and which application has an issue, so that we can fix accordingly. That particular configuration we need to when we are setting monitor for an application.
Because we have a fintech product where we were trying to set up multi-cluster, the same product, but the biggest challenge was traceability. We were not able to find out what.
This is one of the small disadvantages of multi-cluster. We have to have multiple configurations and multiple monitoring systems. We need to have
It became a very good, very big overhead for us to identify when something happens in production.
Yeah.
It's like
that's why we should have a individual setup for individual clusters. If possible, you can set up for individual application under the clusters also, so that you can say which pod has an issue, so that you can easily identify which pod has an issue and we can resolve it.
So normally, right? So you wouldn't go for multi-cluster architecture unless and otherwise it is necessary, and especially with the sophistication that you get in these cloud providers, right, where you have multiple availability zones, or certain cloud providers allow you to create a Kubernetes cluster across the availability zones and across the regions. Probably that is something you should try. And as he pointed out, if it is a multi-cluster architecture, these two clusters have to be communicated. The traditional way to do that is kube federation. And the modern tools like Istio, Calico Mesh, all that supports it. But it would complicate a lot. Rather, it's better to go with creating a cluster across multiple availability zones. And even if you make multi-cluster architecture, right, your request coming to that cluster dependent on other cloud services. So if the entire cloud is gone, even this will not work. So it's better to go with a cluster across by having a nodes across the availability zones or across the regions. Probably that would help, and that would help you in the observability aspect as well.
Right? For example, you are using an API. The trace ID is that, right? We can pass from one service to another service also.
Yeah.
For example, that is also you can pass it. So the same trace ID can be used. So all the logs you can aggregate it will be. But we have to put effort, definitely. One service is pointing to another service. Definitely the trace ID you have to pass. How we done it? For example, we have our front ends are deployed in OpenShift. So the front end will create one trace ID. The backends are in same GCP, it is in cloud. So the trace ID we will pass it to front end to backend. So while you are searching it, but it's in same cluster with what you are doing here. But it can be done different also. So if you are passing it while you are searching it, everything from the user to everything you can search.
So the aggregators and trace ID, that's
Correct. Default.
But the only problem is I have to go through two cluster instances to trace what really happened.
Correct.
That's where the complexity stands.
maybe you have your data or your address, anything, right? Everything you need to aggregate it from there, also we can use it.
I do have a question around the network segmentation which you have. Where does that happen? For example, I'm getting that information which what he has. Let's say I have a service A in cluster 1, then I might have the same service in cluster 2 as well. So in one of the part you mentioned that if we can make sure it is going across the same cluster environment, we can avoid the bad request. Where does handle? Is it handled out of the box or is it based on some kind of headers probably from the request or request? How does that happen?
Right. What is it you are asking about across multiple clusters or?
Right. So there is a part about the network segmentation, right? So which means that if I'm sending the first request, I have a set of services on cluster A and the cluster B. So if I want to access the account service on cluster A, which is going to talk to another service, maybe a subscription service, instead of let's say the next request is coming to the subscription service, which may not go to the cluster B, instead it can go to the cluster B. Am I understanding that right? You have said that that will create a bad request. Yeah.
That's why I mentioned like a cross cluster alerting.
Right.
So it is a key thing that we need to configure in our monitoring observability.
Okay, got it. Where does it gets managed? Whether the request should go to cluster A or should it go to cluster B? Where is determined?
So that's why in insert values and global config you mentioned into federation we have to configure because each cluster will have a separate application. Each application will have a routes path and everything, right? Then we are configuring. So if it has matching this particular path or not, the request will go to the particular cluster.
Okay, got it. So you're saying that for two different versions, not for a same version. Okay. Okay, cool. So I was just thinking if we have a same version on two different things, should it go to the same cluster for
Same version of two different clusters.
same version in two different multi-cluster?
In that case, one cluster will be act as a primary, one will be act as a secondary. So all traffic will go to only to primary. So if anything happens, it happens in primary cluster. Then you can switch off the traffic from primary. Then we can send all traffic to secondary cluster.
Got it.
It will be used for disaster recovery or to improve application
I understand. Thank you.
Thank you.
Thanks, Pastor. We'll have the feedback for the session today. So please scan the QR and share your feedback. Next, we'll have session 3.
Hello. Yes. Hope you all can hear me. Yes. So, today, loading, in any website today, we go into Google, we try to shop something, like want to buy a t-shirt, I search in Google, I search for t-shirts, I get a bunch of links. Now, when I click on a link and I try to purchase something, and the browser starts spinning like this, right? It keeps us thinking, did I click on a fraud website? Is the site broken? Is there some sort of an outage? Right? Gets us thinking, or even if I'm desperate, I'm going to still wait for it. Probably I'm going to switch to Instagram. Okay, let me, while this looks, right, let me go to Instagram and watch a reel. Right? And I start scrolling, and I'm gone. Right? So I keep scrolling forever. So just like that, we just lost a customer. Right? So today we will see some techniques in server-side rendering on how to make this experience in a more optimized way. Welcome to today's session on next day's e-commerce, beyond loaders, mastering interactive UX. I'm Vignesh Shurma. I've been in IT around 12 years, mostly around retail and e-commerce. So happy to share some time with you today to share my learnings. Thank you. Well, dive right in. So we'll start with discussing about a traditional client-side rendering. Okay. So in a common React application, what we know is, in a client-side rendered application, so all the, but once we hit the URL, it just then downloads a blank screen with a simple HTML like this, where it only has a JS download. All of our HTML that as part of the application is bundled into one JavaScript. That is first gets downloaded. So first the page gets downloaded with a blank screen, nothing is in it, content in the HTML. So it shows a blank screen, and then it starts to download the JavaScript, and then once the JavaScript is downloaded, now we got the HTML contents. Now it renders the shell component, which we call, let's say I made a loader. Then after putting the loader in place, now we get make a call out to get the data to paint the rest of the page. So this is traditional client-side rendering. So whereas in server-side rendering, so we anticipate this. Let's say I wanted to paint, instead of painting a blank page, I will fetch the data first. Once the user hits the URL, I'll fetch the data first, render the entire HTML, compile it on my server side, right, and then give something, give a painted page instead of a blank HTML. Now I got a full HTML, painted HTML, right? And then once the HTML is downloaded, now the user can, instead of staring at a blank white screen, now we actually stare at the proper content, right? So now the JavaScript for that page gets downloaded, and then the hydration starts. The hydration process is basically to make the interactive elements like links and buttons to make it actionable, right? So this so this way, instead of staring at a blank page, we get a good experience where the user gets to see the content. But like we saw on the first screen, right? During this time, while this data is being fetched on the server, right, and then until it paints a page and response, the user starts seeing a loading spinner on the browser. So to mitigate this issue, so let's think about how about doing this parallel, right? So the download JavaScript, let's bring it in. Right now, from the server side, I know this is the JavaScript that I want in the browser. So why can't I do this parallelly, right? While the data is being fetched on the server side, why not push this forward so that there will be a quick feedback for the user, right? So let's say look at this technique. We are going to look into streaming, right? So in this experience, like I said, so first, now that I know, so this is the shell component, that I'm going to, I plan it ahead. That, okay, so this is the shell component I will show while the data is being fetched. So soon as I get the request, first I send the partial content of the shell component. Now that because I know what is the JavaScript I want in the browser, while this keeps downloading, the data fetching happens on the backend parallelly. Right? So now, so this is a partial download. Right? So once the data is fetching is done, now we render that piece of content and then later download it as the second one. So while this is downloaded, the JavaScript is already downloaded and the page is hydrated and ready for the rest of the contents to be painted. Right? So this way, we optimize the time and the user gets a quick feedback, without having to wait for the data fetching on the backend. So just to, we'll say a quick demo of this. So I have a quick short demo application. So we'll see first the traditional server-side running. So I have intentionally given a 6-second delay of my API so that you could see the delay here. So we could see that in the first request, so when I first hit the URL, sorry about the crappy UX here, but in the first request, so we could see that it has taken about 6 seconds to respond. So I intentionally set the backend to take 6 seconds. Right? So it does the data fetching, and the data fetching process took about 6 seconds. Whereas we'll quickly see a demo of how when it works with the streaming. So here we could see that we immediately get a feedback. At the same time, the data is being fetched on the backend. We still see that it is the browser is spinning. And so here notably, the first request, we still see that it has taken 6 seconds. So the difference is, right? There's no difference. We are not compromising on the data. It is still the same request, just that we have just added additional technique here to first download a chunk of it and then download the rest of it later. So for example, in old days when we download a movie in torrent or a YouTube video, while it downloads, we try to play it with the VLC player. It only plays that piece of video, that is getting downloaded and makes us frustrating, right? So similarly, this is like same way that so instead of downloading the entire HTML, we decide what has to be downloaded first. Right? So that now, so this process of chunking the response into what we want to download first and the entire HTML chunking it is what we call as the streaming. So how do we accomplish this, in latest React and Next.js? So so we'll see that in a short piece of. So this is the first piece in Next.js. It's a simple Next.js application. In the first approach, where in the traditional server-side hunting, you could see that we fetch the data. We fetch the data first in my first component. It waits for the data fetching to be done. It's a simple API call. It waits for the data to be fetched, and then later it paints the page. Right. So this is so now this line takes about 6 seconds until it moves to the next line. Right. So whereas in a streaming way, so how we are going to leverage streaming here is, so React provides a hook called suspense. Right. So we are going to use the suspense to control what should be downloaded first and what should be downloaded next. So here, using the React suspense library, so we import the suspense from React and wrap my component, and that I intentionally tell, so wrap my component that downloads this content and make the API call intentionally and dictating. So do not wait for this element data fetching to be done. Instead, while this data is being downloaded, show me a loading component, right? So now this is going to indicate my React server components. Okay, so what to wait and what not to wait, right? So this way, I have a control of what is the first chunk that gets that I want to show to the user, right? For Next.js users, in the latest Next.js versions, so what we it provides is, so now instead of using suspense, so we can directly use this loading.tsx into the root folder, so that I do not have to manually wrap my component with the suspension. So Next.js does this out of the box for me just by using this loading.tsx, and the syntax and the file name has to be strictly followed. So this loading.tsx is automatically applied at a page level. Next.js does this out of the box for us, right? So now I'm design, for example, I'm going to a product detail page, right? But I do not want the user to see a loader across the entire page. I want to at least show him some content, some image, some description, so that he doesn't see an entire loader on the first page. So now I can selectively decide what I want to show, what I want to wait for the data fetching, and what can be dynamically done with suspense, right? So this process, in those cases, we can remove this loading.tsx at the root level and use the suspense on selectively which component that we wanted to stream. So this process is called selective hydration in Next.js, right? So using this process, we can achieve that. So now that we have looked into some server-side techniques, so what are some common challenges with respect to server-side rendering, right? So one of the common problems, for example, if I'm in a shopping cart, right? So in a shopping cart, as much as I want to render my content on the server side, I also have a lot of interactivity on the client side that I had to re-render my entire page again and again. For example, I can apply a coupon code, a promo code like Swiggy, right? So once I apply a coupon code, I need to re-render all the prices in my products, based on the new data, right? So I don't want to go to the server and put a loading on the page. I want to do those things on the server, on the client side, right? So in those cases, I had to do both. I want to go to the server side rendering as well and client side rendering as well, right? So that is, so in this case, how do we manage, right? And also, we have to be careful about what is the data that has been used to render on the server side, and it has to be matched on the and hydrated on the client side. And Next.js luckily does this for us out of the box. And there are some client side only elements. For example, there is a button component, right? So this only works on the client side. So I need a separate JavaScript so that it can attach a click event to that element, and so these kind of things cannot be done on the server side, right? So now with the React server components, right? So with the React server components, so this is a traditional React server component. So how do we make sure that if I wanted to do interactivity, or if I wanted to like button click elements, attach a click event, right? Or if I wanted to do dynamic rendering, like I want to re-render the page using state management, like redirects or context, React context, so that I can keep re-rendering on the client side. So how do we do this in a typical React server component? Normally, React server component does not allow all these React hooks that we use for state management, like useState, Redux, Zota, Sustain. All these tools actually doesn't work with the typical React server component. So to mitigate this, the React team provided a client directive, a use client directive. So what it is, so on the page, top of the page, so we indicate, so for in this example, for example, you can see that I'm using, for this demo, I'm using a React context API where I'm using a provider component, which is a React context, which uses React context API. So here, you can see that, so even though this component is going to be loaded on the server, I have used the use client directive to indicate that this component needs reactivity on the client side, which means this component has some data that is going to be re-rendered on demand on the client side. This could be due to any activity, right? So this way, I'm marking this component as use client. So this makes it, so now we are going to call this as a React client component. So the earlier one where it didn't have a library is called the React server component. Now with the use client, now we are calling this as React client component. So the difference between this is when I mark a component as a React client component, so now I need that, so I need this component as a this JavaScript on the browser, because I'm going to need some reactivity based on the dynamic data that I'm going to do based on the click interactions, right? So now, which means this gets added to the client bundle, the JavaScript that gets shipped to the, whereas on the any server component that we paint on the server side, doesn't get added to any JavaScript. It's just brings the HTML and that's it, right? It doesn't add anything to the JavaScript. So now, let's with this naming convention, React server component and React client components, right? Just by this naming, it often confuses us. Like, okay, so client is browser, right? So how does this work on a server side, or server component is server side, but does server component work on a client side? Often this, confusion happens, right? So let's say a quick slide about this, right? So a React server component renders only on the server. It does not re-render on the client. Whereas when I mark a React client component, so it works both on the server side and it helps with re-rendering on the client side as well. So this is some common, misconception where, just by the name, we think that, okay, a client component only works on the client side. But so this way, React introduced this directive so that it helps us do effective state management on the server side as well, so that we can manage the data between all my components. For example, in the shopping cart, I may call a single API, to get all the card data, but I don't want that in about 50 components, to construct the entire shopping cart, right? So, and in these cases, client components come in handy. So now, thinking about this, and with selective hydration, for example, with streaming as well. Now, going back to streaming, so we may think that, so now with these kind of techniques like streaming, I do not need any client-side logic at all, right? I can do an entire product detail page, for example, recommendations, recently viewed, all these entire page, I can do even lazy loading from the server side. I don't need any client JS at all, right? So with streaming. So, but this could be tempting. As much as it is tempting, it comes with some cons. So, when should we use streaming and when should we not use streaming? Right? So, for example, when I use, in this case, for when it takes about in a product detail page, let's say, right? If it takes 6 seconds, SEO is not going to like it, right? Even though we do use streaming, but the network call took about 6 seconds, right? And so that is going to be a disadvantage for us with respect to SEO rankings. So that is why we need to find the proper line of balance between, okay, when should we do lazy loading of our components and what should we do on the server side. So, this balance is especially needed for e-commerce so that we do not lose our ranks in the SEO, right? So this way we need to find, find the right balance with respect to using suspense and streaming. So with respect to using client directives, so as I said earlier, so making any component as a client component is going to be shipped to your browser in your JavaScript bundle. So when it does that, so it is going to increase our bundle size, right? So now that we know that I can do state management, I can use Redux, Zustand, or anything now on the server side component itself with using the client directive. It is tempting that, okay, I can use state management across all my components and keep my components cleaner, right? But it does come with its cons. So what is the balances? So we need to make sure that if there are no reactive elements necessary, for example, in a shopping cart product detail page, if for example, there is a product description, that's not going to change as long as I'm in the page. There's going to be a product image, that's not going to change. So there is so all these components doesn't need any reactivity. Whereas in the shopping cart, I could change the quantity, that's going to need reactivity on the price. I could apply a promo code, whereas that is going to have an effect on the price. So there's a lot of reactive elements that is necessary. So this is how we need to identify: is it worth adding to the JS bundle so that we can see an opportunity to optimize the bundle size and bring in better performance. So in a product detail page, in this case, I would use server-side components, and try to avoid any state management or client components as much as possible, and limit my code to server-side components. Whereas for a shopping cart, I could leverage client components. So this is a good trade-off, doing. So that's where we need to find the right balance between, leveraging performance by effectively using these techniques, right? So yeah, so that's about what I had for today. So hope you all were able to gain some. Happy to answer if any questions. Great, thanks everyone.
Thanks, Vignesh. Thanks, Vignesh. That was a wonderful session. Yeah, just a second, we are connecting the laptop so that you can scan and give the feedback. I really would appreciate all the three speakers what we have had today. So they have spent a lot of time and they have made this session so wonderful. Let's have an applause for three of them. Yeah, so we have completed all our three sessions successfully, but the session is not ended yet. We are so joyed to have an announcement. I would like to invite Bala for this announcement.
Thanks, Neha. Can I request Achu also to join me in this stage? Please come over. Team, we both are leading the platform engineering team in Ford, and this concept of having the meetup, it's almost started a year before. So we joined our hands together, and one of the person who is inspiring for that is, his name is Muthuvaliyappan. He's one of our colleagues working in e-commerce setup. So he triggered a person in our team. Where is May? Okay, so May is also very instrumental in terms of triggering these conversations. He led front end, Chennai web engineering, so front end part. And then myself and Achu, we started joining hands together for doing the platform. And then we have another peer and colleague, Clarence, who does the SR. What I'm going to do as part of this short announcement is just wanted to walk through some quick memory lane. There is a timeline which we have put it through. This is our fifth event today, okay? And we started in November 2024. Our first event happened in our own office building. We talked about repo wars, covering monorepo, polyrepo, dev lake, backstage, faster pipelines, how do we drive through. So 3 sessions, almost close to 141 registrations. At the time, our meetup group has around less than 100 members, around 81 members. And then in December, we conducted the second event, and it's typically again we conducted in 4, and we did release mastery. How do we master the release, and how do we drive the cost-saving cloud, and also CACD showdown. So again, 3 sessions. At that time, our meetup group had around 225 members, and we had good amount of registrations and footfalls. In 2025, we gathered together, and then we have a clear agenda for Chennai platform that we will do 4 events in the entire year, 1 per quarter, and each of this will stand on its own in terms of its quality and the precision. So that's our clear motto, and we will stick to the platform engineering wider concepts. We will also collaborate with other teams like web front end and SRE and join hands together. So in that way, And also we took a clear decision. We want to go out and start collaborating with the community. So in that way, Q1 we did it in M2P. It's in Guindy. It's a fintech software company. We did AI-powered, how do we do the PR reviews, streamline platform engineering adoptions, and sessions. So we did it on the Q1. At the time, our Meetup groups Chennai platform stands at around 477. And then in the Q2, somewhere in June 7, we did AI-driven platforms in Unique. It's an IIT Research Park. So that was one of the good sessions. So we had two key sessions. One is conversational AI, another is MCT related items. So that has a good footfall, and at the time our membership is around 636. And today we are standing in the fifth event, almost nearing a year, almost 10 months over. So we are at 976 as of today. And you have seen this session. But what next? So this type of thinking process, me, Achu, along with me and Clarence, and also we have now recent partnerships from Purush and Uma as well. So we have started thinking, how do we take this to the next level, right? From a platform engineering, we started thinking that why can't we break the ceiling? So next slide. So we want to break this. Why should we have to only have the face-to-face? Why can't we have a hybrid? Everywhere the world is moving towards hybrid. So how do we go towards the combination of having a location-based to the global umbrella? So that's something which started with, and we really don't want to ourselves limit any factor, right? We want to go limitless, and we want to be very purposeful and global. And our quest for excellence is towards engineering excellence, and we want to embrace digital transformation as our prime motive. So with that, we want to re-transform ourselves from Chennai Platform Engineering Group to Global Platform Engineers Network. We abbreviate as GPEN. And this is a small initiative to start with, but we will definitely have a long haul. And we would like to introduce this GPEN as part of today's meetup. And we need every one of you to join hands with us, not just for the sake of following the LinkedIn page or any other social media, but to be the partner in spirit, being a speaker, being a consistent contributor to enrich this forum to the level what we aspire for. And our aim is to connect, learn, inspire, and grow. And in that way, we want to focus ourselves in terms of cloud platform engineering, DevOps, release management, scalability, cloud cost FinOps, cloud security and DevSecOps, generative AI adoptions in terms of AIOps, observability, developer tools engineering to improve the developer efficiency, and performance engineering. So that's the context which we would like to present you, and we request all of you to follow us and contribute us. And if you have more passion and fire inside, please willing to onboard us in our core committee. So we would love to have you. This is nothing to affiliate ourselves as Ford. There are a lot of people here from Ford because of the proximity we gain by working every day, but we don't restrict ourselves. As we break glass ceilings here, we would like to break that as well. So we are widening our network. So please join us on that. With that, I will hand over to Achu for any couple of words, please.
As Paula said, correct. So we started 8 months before actually, 10 months before, right? At that time, we came up, we want to connect with outside flow, not only inside, right? So we want to connect with the industry, how industry is going on. We want to get a good resources and everything, right? We started it. We moved now 10 months. Now, as Paula said, we want to move to the next level so that we can scale it up. Anyone interested, right? It's not to any organization specific. If you are enthusiastic, you want to participate, right? You can join that and then you can contribute. So we can move forward from there. It's like we will take it from you, right? That's especially what Paula said. We want to take it forward.
Thanks, Achu. all these are all not possible without the core team, right? So I'm just being one of the part of the volunteering ship. So there is a huge team who are all behind this in all this journey. I sincerely thank me and Achu on the behalf of Chennai platform for all the organizing committee. So with that, back to me. Thank you.
Thanks, leaders. That was a really great speech. I definitely tell that it wasn't a cakewalk. For 1 year, we have gone through like so much, and we came here. So before this, we'd like to have a teaser for this one. Let's just. Audio can audio is not coming immediately.
It will come. Just try it out.
No, it's playing in my laptop.
Oh, okay.
This needs to be my laptop.
I'll give your mic probably into the speaker.
Yeah. Yeah, we'll have a survey. Just a second, please. Slide. Please scan the QR and I see participants that typing, so can I move on to the next question? So here is the next question. Would you like to present your topic in our next meetup? Can you please give your details? Yeah, I'm switching up for the next question. So what are the topics that you would like to hear from us in the future meetup sessions? Please post your answers. This will help us really.
Okay, we'll come to the end of the session. So now I want to thank all the leaders like Bala, Meetup, and Uma, and Purush, and Achudan. And also I would like to thank all the speakers who have took the session wonderfully, like Vignesh, Pastor, Gauri. So, and really appreciate the people who have came and even the participants in today's meetup as it's on Saturday, and really the session went well. And now, like, we'll have a team photo, a group photo. So can you all come forward so that we can have a picture?
வீட்ல இருந்து வேலை பார்க்கறதுனால அவனை பார்க்கவே முடியல. அங்க போனா நல்லா என்டர்டைன்மெண்ட். பக்கத்து தெரு
Yes, some of the people can. The place in the middle is challenging. Yeah, we can leave
Can you avoid these chairs? Or should we move? Should we move? Should we move?
We'll have a lunch and so lunch is provided in the first row. And whoever is looking for opportunity, you can scan the QR code expecting the door for any opportunity job. It's perfect.